Let's get started. Okay, this is a problem that deals with product notation. So I'm rewriting this expression in terms of its exponential form. Okay, again, 0.0625 is equal to 1/16. That's easy to verify. And then using properties of exponents, writing it with a negative exponent. This is 1 over 2 to the 4th, 2 to the minus 4. And so this left-hand side would be equal to let's just write this out. It would be 2, let me just write it, folks, 2 to the minus 4 raised to the 32nd power. Equals to 2 to the minus 128. Okay. So now this is a nice thing because this right-hand side is 9 powers of 2 multiplied together. Okay, and so we have the left-hand side in terms of a power of 2. So that's useful. Now, right here, let's take a look at what we would have to do to handle the evaluation of this product notation. For I equals 1, you would have 2. Let me get this. You would have 2 to the x. Okay. Again, folks, that's for I equals 1 right there. Now, next to it, you would have 2 to the 2x, that's for I equals 2. Okay, and we'll just do one more here. The next one for I equals 3 would be 2 raised to the 3x power, and we are trying to find x here. Okay, and let's go ahead and put the customary ellipsis here, dot, dot, dot. And the very last one in the series would be 2 to the 9x. Okay, now here's where we have to do a little bit of work, but not much. Now, the properties of exponents says that you add exponents in this context here. And so if you take a look, since x is common to all 9 of the exponents, okay, we can rewrite this as 2 to the x, and we'll factor it out. We're actually doing the work in the exponential part of 2 here. Now that's going to be the sum. Okay, you're going to have x times 1 plus 2. Okay, plus 3 plus 9 all the way out. Now, a lot of you guys probably recognize this is there's a sum. These are the triangular numbers, basically. And you can add, when you add those up, it's the very same thing as, let me just, do I have room over here? Yeah, I guess so. Okay, so we'll do equals. Now, folks, the way you handle this is it's 9 times 10 over 2. Okay, so I'll just write that down. So this would be 2 to the x. Again, folks, the way you resolve the sum of the first 9 natural numbers is to take the last one, multiply it by 10, and then divide by 2. But that would give us 45x. Okay, folks. And I trust that a lot of you guys know that. I guess I should write it down somewhere. But the sum of the first n integers is just n times n plus 1 over 2. Okay? So that's what happened there. I'll go ahead. I feel guilty. All right, so y'all, if you have 1 plus 2 plus dot dot n, okay, that's equal to, and that's not a hard proof actually. You can do it in a way that doesn't even involve induction. N times n plus 1 over 2. Okay, and if you notice, that's exactly what I did right here. It's just that your n was 9, so this would be 9 times 10, which is 9 times 5, which is the 45 that you see right there. But you see what we can do right now is, because this is the right-hand side this is the left-hand side of the equation right here. Okay, folks, this piece right here is the left-hand side of the equation. And then this piece right here is the right-hand side of the equation. So all we have to do is equate, and I'll write this as 2 to the 45x. Okay, so all we have to do is equate 2 to the 45x with 2 to the minus 128. And folks, since this is a one-to-one function, and a lot of people don't mention that, it's a one-to-one function. The exponential function is 1 to 1. We can equate these two exponents. We can equate this with this. And when we do that, we'll get x is equal to minus 128 over 45. Pretty cool. And y'all, you would have expected this to be a negative number, since negative exponents applied to positive bases are small, very small numbers. So this is not, the negative sign's not unanticipated. And that's the final answer, folks. A number a little bit less than 3. A little bit less, or a little bit greater than negative 3, actually. Alrighty, everybody. Hope you enjoyed.